Hi guys, so today we're going to look at how to solve absolute value equations. So what we're going to do here first, we're going to look at a few of these properties. So these are actually two separate properties. I didn't mean for them to be so close together there. But one of those is that the absolute value of any number is greater than or equal to 0. Because remember what absolute value means is how far is that number away from 0. So the absolute value of -5 is just 5. The absolute value of 6 is 6. All right, and that also helps tie in that second property. We'll use those bottom two in a few more examples. So the steps for solving absolute value equations. The first thing we do is we get the absolute value by itself if it's not already. So that's already done in the first one. Then what we need to do is we actually need to set up two equations because the absolute value of x minus 3 or x minus 3 could equal 7, but the absolute value of -7 is also 7. So I also need to set up an equation where it's equal to -7. So I'm going to solve both of those to get my two answers. So I get that x equals 10 and x equals -4. Now, what we also need to consider is this last step on here where it says check for extraneous solutions. It is very important in Algebra 2 with a lot of the functions that we look at that you plug these answers back in and you make sure that they actually work. You will get some answers sometimes that are extraneous, and what that means is even though the algebra worked out, when we plug it back into the original, it doesn't actually give us the correct answer. All right, so now let's look at B. So two equations that we would need to set up, but before we even get there, we can save ourselves some time if we consider the question that we have. The absolute value of 3x plus 1, we want that to equal a negative number. Well, absolute value is never going to equal a negative number. So before we even try to work this out and plug in our answers, we know that this one's going to have no solution. Another way to look at this, if you remember, every equation that you work out is really just the intersection of two lines or two graphs. So if I were to consider this as a graph, 3x plus 1 is an absolute value graph. It's going to be shifted to the left one. It's going to be stretch sum. It's going to look something like that. The other graph is the line y equals -5, which is a horizontal line down here at the bottom. Those two graphs will never intersect, so there's no solution for that equation. All right, so pause the video and go ahead and try C. All right, so what happened here, we first got the absolute value by itself, and then we split it into two equations. We set it equal to a +6 and equal to a -6, and then we solved both those equations to get two different answers, x equals 4 and x equals 0. If I plug that back into the original, both of these equations would work out, so both of these answers work. So now let's try D. All right, same idea, two equations. The absolute value is already isolated, so that's equation number 1. Equation number 2, I'll go ahead and put over here. All right, so I want to go ahead and solve this, so I end up with x equals 6, and, oops, I forgot my negative. It's the same equation. Sorry about that. That's a -4, that's a -6, so x is equal to -2. Now, the problem with this one, if I plug these answers back into the original, so if I take that x and I replace that x with -2 in both that spot and in this spot, I'm going to end up with the absolute value of 8 is equal to -8, which is not a true statement. That means that -2 is an extraneous solution, and we do not include that as an answer. So the only answer that we have in this case is x equals 6. Again, if we consider this graphically, what's happening, 2x plus 12 would be shifted to the left and stretched a little bit, so it's going to look something like this. The line y equals 4x, it has a steeper slope than that, but it goes through 0, 0, so it would look something like this. And if you consider that, that's only going to touch in that one spot. Now, that graph is not going to have more than one solution. That's the only place where they cross. All right, what I also want to show you guys on this third example, I want to show you guys a different way to look at example C. All right, so I'm going to rework this one. Well, let me leave it at this step. And I want to show you guys how that other property works, because that's something that can help you guys when you get to these graphs. So one thing I can do here is I can factor out that 3. What that allows me to do then is I have 3 times that factor. Well, using that property that I have here in the bottom left, what I can do is I can separate that multiplication into 2 different absolute values. So I can make this the absolute value of 3 times the absolute value of x minus 2. Well, the absolute value of 3 is just 3. So this is now 3 times the absolute value of x minus 2 equals 6. So if you were struggling with any graphs on the last homework assignment that had compressions or stretches that were horizontal, this is the idea that you can use to pull that out so that you can look at it just as a vertical stretch or compression instead. Now, if I were to go back and solve this, I would do x minus 2 equals 2 and x minus 2 equals negative 2, and I'm going to get the same answers. You do not have to solve these this way, but I wanted to show you guys an example of that property. All right, so the rest of these, it's going to be the same process. It's just going to be a little bit of a more complicated, some of these will be a little bit trickier. So let's go ahead and look at E. So again, the absolute value is by itself, so I'm going to set up 2 equations. X plus 8 equals negative 2x minus 2. And I'm going to do x plus 8. I don't know why I did 2. I apologize, that's supposed to be 1. X plus 8 equals positive 2x plus 1. All right, so again, on this one, when I change the signs, notice that I changed the sign of everything that came after. So I'm making the opposite equation completely negative, not just putting one negative in front. I have to apply it to every term. So now when I solve this, I get that x equals negative 3. And x equals 7. I can plug both of those in. Both of those will give me solutions that work, so there are no extraneous solutions. All right, go ahead, pause the video and try F. All right, so if you worked this out, when you did x plus 5 equals x plus 11, you would have noticed you ended up with 0 is equal to 6. That is never going to happen, so we're not going to get any solutions from that equation. The only one that works out is going to be this x equals negative 8. And again, if we consider the graphs of these, x plus 5 has been shifted to the left 5. X plus 11 has been shifted to the left 11. So the intersection of those graphs are only going to intersect in one place because they have the same slope continuing in both those directions. All right, so let's try this next one. Again, same idea. We just need to remember to apply that negative to everything that follows. So here's equation number 1. And then equation number 2 is going to be 5x plus 12 equals negative 2 times 4x minus 1. And then we can go ahead and finish solving these out. So I'm going to get that 3x is equal to 14. So x is 14 thirds as one answer. Finish working this one out. And I get that x is equal to negative 10 thirds. So again, I could take these answers, plug them back into the original, make sure they're not extraneous. And they do both work. All right, looking at H, not super complicated in the setup, but it requires a little bit of Algebra 1 review in order to find your solutions. So one equation on here, I've got x squared minus 3 is equal to negative x plus 3. My second equation, I'm going to go ahead and put further at the bottom here. I'm going to have x squared minus 3 equals positive x minus 3. So since this is quadratic, the easiest thing to do is to set it equal to 0. So if I set this top equation equal to 0, I'm going to have x squared plus x is equal to 0. So then I can take out a GCF, and I get 2 possible answers, x equals 0 and x equals negative 1. Then let's go ahead and solve the bottom. So I would set this equal to 0. And I would realize that I put my answers a little bit ahead. I apologize, guys. What I just showed you is going to be for the blue equation. So -3 minus 3 would be -6. So this is going to factor x plus 3, x minus 2. So x equals -3 and x equals 2. All right, now finishing off the second equation. Oh my goodness, I keep doing that. I apologize, guys. This is the one when I add that up, it's going to equal 0. So I'm going to take out my x. I'm left with x minus 1. X equals 0, and x is equal to +1. So these are my 4 potential answers. From here, I need to check and see if there are any extraneous answers. It's possible all 4 of them could work. It's possible something else could be the answer. So again, I need to plug these in to my original and make sure that all 4 of them work. And in this case, all 4 of these solutions are possible for this equation. All right, on this next one, again, we need to consider multiple possibilities here. So what we have is an absolute value inside of an absolute value. So this first thing, what I'm going to do, since this big absolute value is already isolated, I'm going to go ahead and set up 2 separate equations. I'm going to do the absolute value of 2x plus 5 minus 3 equals 10, and I'm going to do the absolute value of 2x plus 5 minus 3 equals -10. All right, because again, that is dealing with this absolute value, setting up 2 equations. All right, so I can go ahead and solve this blue one. So that's going to give me the absolute value of 2x plus 5 equals 13. And then from there, this is now going to break up into its 2 own separate equations. So 2x plus 5 equals 13. And also 2x plus 5 equals -13. So I can solve both of these. So solving that blue equation, I'm going to end up with x equals 4. Solving my red equation, I'm going to get x equals -9. So now from there, I can continue solving that equation that I had in purple. So I would get that absolute value by itself. And then from there, I would set up 2 equations. However, if you want to save yourself some time, if you can recognize at this step, what I have is an absolute value equal to a negative number, we know that's not going to happen. So even though if I was working this out, it could potentially have 2 more equations, in this case it does not. This branch of this equation does not have any solutions, so our only possible answers are x equals 4 and x equals -9. Again, I should plug those back into x to make sure that I get an answer that works for those. J is actually not too different from a question that we've already seen. There's just one little trick to J, and that's one of those properties that was listed at the top of your notes. If I have a fraction like that in absolute value, I can separate that into 2 absolute values, top and bottom. And now, if I want to rewrite this, I can rewrite this as x plus 1 and then 5 times 3 minus x. That way I don't have to look at that fraction anymore. And now it's going to be a very similar question to an earlier example. So go ahead, pause the video, and try and complete this one from this step. So I end up with x equals 4 and x equals 7/3. So let me go back through those steps for you. All right, so what I have here on this first one, again, I separate it into 2 equations. All right, so x plus 1 is equal to the positive of the other equation. Work that out, and I get my 7/3. That does work out. It's not extraneous. Option 2, I set that up equal to a -5 times that. Go through that equation, and I end up with x equals 4. Neither of those are extraneous. So the last equation that's on here is probably one of the trickiest because, again, there are multiple cases that can happen here. So we need to consider 4 possibilities with these absolute values. One possibility is that both of these end up with the positive answer. One possibility is that one is positive and the other is negative. The other possibility is that both of those are negative. So we're going to look at all 4 of those cases to see which solutions we get that will actually work out here. All right, so 4 equations. So one of them, we're going to keep them all positive. All right, that's option 1. So all positive. Option 2, we'll do the first one as negative and the second one as positive. So negative 3x minus 2 plus x plus 2 equals 6. Option 3, still one positive, one negative, but we flip them. So we'll do 3x minus 2. I don't need parentheses at that point. And then we'll make the second one negative. So that was positive, negative. Then the last option is if both of them are negative. And I'm out of space. I'm going to put that down here at the bottom. So we'll do negative 3x minus 2 minus x minus 2. So each of these equations is going to yield its own possible answer. Then we would take those answers, plug them back into x, and see which ones actually work out. So go ahead and pause the video so that you can at least just solve these equations for x. All right, so I end up solving those 4 equations. I get 4 different answers. Out of these 4 answers, if I were to substitute them back for x, 2 of them are going to work out and 2 of them are going to be extraneous. So if I plug in 3 over 2, that will work. If I plug in negative 1, that will work. If I plug in 5, it is not going to work. That would give me 13 plus 7, and that is not equal to 6. And then negative 3 over 2, whoops, I erased it, but I can because it's an extraneous solution. That also is not going to work. So this one, after all of that work, we end up with 2 possible answers. All right, the last thing that we're going to look at are just a couple word problems and just some applications of these absolute value questions. So that first one says the average temperature in Texas the average temperature in Texas in July is 96 degrees. The actual temperature may be 10 degrees cooler or warmer. So while you can probably tell what the highest and lowest temperatures would be based off that information, we do want to be able to show an absolute value equation, at least just to get in the habit in case we have different variables in the future, so we can get used to seeing what that's going to look like. So since it's going to vary by 10 degrees, we know that the change from that temperature is going to be 10 degrees. So what we're doing then, that temperature, what we're going to do is we're going to do x minus 96 degrees. Because even if it's a smaller number and it gives us a negative answer, since we're looking at absolute value, that's okay. It won't matter. So that's how we can express this with an absolute value equation. Now I know just from reading the equation, or just from reading the question, you can probably tell, hey, 10 degrees cooler than 96 is 86, and 10 degrees warmer is 106. And yes, that is the max and the min, but it's important to understand how we can view this as an absolute value equation, because we'll use this concept within other things later on this year. So then again, if you were to actually work this out, x minus 96 equals 10, x minus 96 equals negative 10, so I do get those 2 answers from solving it this way. But it is important to be able to take that information and process that into an equation and not just find those values. All right, this last one. We have Jim passing a basketball to Dwight. He's bouncing it. He is holding it at a height of 4 feet, and then it bounces 3 feet away from him. So we know that this is a height of 4, and this is a height of 3. Dwight is standing 2 feet from where the ball bounced. So we're going to go another 2 feet from there, and we don't know the height that he reaches it. So what I'm going to do is I'm going to turn this into a little coordinate plane. All right, so I'm going to say that here is 0, 0. So the height of the ball then originally, it said it was 4 feet, so this is going to be at 0, 4. That means at this point here, the ball bounced 3 feet away, so that's going to be at 3, 0. And then we do not know the height there, so the height is going to be, we're 2 feet past where it bounced, so we're at 5. Apologize, that's backwards. No, that wasn't. We don't know our height. So what we're going to do is we're going to write an absolute value equation kind of for that graph that I just drew. So that graph there, we know if that was 0, 0, we know that graph has shifted to the right, so that's x minus 3. It has not gone up or down. We don't need any shift. And then the stretch on that graph would be basically the slope of that line. Well, that slope, I've gone up a distance of 4 for every 3 that I've gone over, so that's 4/3. So that's the equation of that absolute graph that's on there. So what I know on this problem, I know Dwight is standing 2 feet from where the ball bounced, which means that Dwight is standing a total of 5 feet away from that original pass. So that means that if I plug in 5 for x, then I'll be able to find that height that comes with that, which is y. So I get 4/3 times 2, which gives me 8/3 of a height, which would be 2 2/3 of a foot. All right, so that is absolute value equations. Next class, we're going to look at absolute value inequalities.